2.7 combinations of function and composite functions. So we're going to first look at the combination of functions. And so the way we can have those combinations is we could have the sum, where we take two functions and add them together, or we could take the difference, where we subtract two functions, the product, we're going to multiply, and then last will be the quotient right here, where we'll divide them. And so what we're going to do here is we'll give an f function and a g function, and we'll look at these different combinations that we can create. But the first example I'm going to do, I kind of want to show that these do hold. These are equivalent to each other. So f plus g of x is equal to the f of x plus the g of x. And same for the other three here. And so on this first example, what I'm going to do here is I'm going to find f of 3 and g of 3 and add them together. And then what I'm going to do here is I'm going to go ahead and find f plus g of x. And once I figure that out, I'm going to plug in the 3 again. And we'll see that, yes, indeed, the two sides are equivalent to each other. And so here we go. Let's see. So on this first one, f of 3. So I'm going to plug in 3 where I see x right here. So we're going to have 7 times 3 plus 3. And I'm just going to go ahead and finish this off. So let's see. 21 plus 3 is 24. And then here to g of 3. So now I'm going to plug in 3 for my g function. So plus, let's see, 3 times 3, take away 4. So then that would give me 9, take away 4, which would be plus 5. 24 plus 5 is going to give me a total of 29. Okay, so what we're going to do here now is I have the notation here for the sum of f plus g of x, which is equivalent to f of x, plus g of x. And so what we're going to do is we're going to leave the x's in place for right now. So on my first function, the f function, that's going to be 7x plus 3. And then for my g function, and this I'm adding the two functions, so plus 3x minus 4. And what I want to do here is just combine my like terms. So I have 7x plus 3x. That'll give me a total of 10x. And then let's see. Then 3 take away 4 would be minus 1. Okay, so that's what f plus g of x is equal to. That's what that is right there. And to be honest, that's how we're going to do most of them. Most of the time we're not going to, well, every once in a while we'll evaluate them at different values, but for the most part we like to just leave the variable there in place. But just to show you that these two things will be equivalent, what I'm going to do here, now that I know what f plus g of x is in terms of x, right here it's 10x minus 1, I'm going to go ahead and plug that in part C right here. So I'm plugging in 3, right? So I'm going to plug in 3. So I'm going to have 10 times 3 take away 1. Well, 10 times 3 is 30. Take away 1 is 29. So the whole point of this exercise was to show that I get the same result if I split it apart and plug them in individually, or if I actually go ahead and combine the functions by addition and then plug it in, I still am going to get the same result. And that will be true for all 4 of these. But moving forward, like I said, for the most part, we're just going to leave the variable as x. We're not typically going to substitute a value in there. So moving on to part D, we're going to do the difference. And so the key here is you need to understand that this is the same thing as g of x minus f of x. And now you have a definition for each one of those. So for g of x right here, we're going to replace that with 3x minus 4. Now this is key. I have to have this minus here. And when I plug in the f of x, I actually want to put that in parentheses, the 7x plus 3. It's very important to have that in parentheses because that subtraction needs to be applied to the 7x and the plus 3 right there. So let's go ahead and do that. So I'm going to distribute here and here. So I still have my 3x minus 4, and then this becomes minus 7x minus 3. And then just like on the one above it, we're going to combine our like terms. So 3x minus 7x is negative 4x. And then a minus 4 and a minus 3 combined together as a minus 7. And that's what we're looking for right here. So that's what g minus f of x comes to once we simplify that and subtract the two functions. Okay, the next one's going to be multiplication. So once again, this notation stands for taking what f of x is and multiply it by g of x, and those are defined up above. So the f of x from up above is defined as 7x plus 3, and the g of x is defined as 3x minus 4. So if you look back up here, that's what those were defined as. And so now what we're going to do is we're actually going to go ahead and FOIL this. I'm going to FOIL this. So multiply the first two, that's 21x squared. Then the outer, let's see, that'll give us minus 28x. Then the inner, that's a plus 9x. And then the last two multiplied together, 3 times a minus 4 would be minus 12. And then we can go ahead and combine those like terms in the middle. So we do have the 21x squared, and then this is going to become minus, let's see, what is that? It's going to be minus 19x, and then minus 12, and we are done. All right, so then now the last one we have is the quotient one for this example. So we're going to look at g of x over f of x. Okay, well, for, let's see, g of x is going to be 3x minus 4, and f of x is 7x plus 3. Now, don't start trying to cancel out x's or anything like that, or the 3's. You cannot do that. What's going on here is this is its own little factor, and this is its own little factor. And if you want to cancel, they have to be identical in order to make a cancellation. So this is going to be my result right there. All right, and I got a couple more of these for us to do. So I've got some new f and g functions defined here. And so it's going to be pretty similar to what we just got done doing. So in this first one, once again, this is just f of x plus g of x. And so f of x right here, we're going to replace that with 6x plus 5. And then for g of x, we're going to replace that with x squared plus 4x minus 8. And so we just want to clean this up. We want to go from highest to lowest on my powers. So we're going to let the x squared jump to the front of the line. Then let's see, then we have an 6x and a 4x, which would combine to give us 10x. And then we have a plus 5 and a minus 8, which would give us a minus 3 when we combine those. And there we go. That's what we're looking for. Okay, part B, kind of more of the same, except now we're going to subtract. So we're going to have g of x minus f of x. Okay, so g of x, which is defined as x squared plus 4x, take away 8. And then we have to subtract the f of x function. We got to remember to put that in parentheses. So 6x plus 5. And I do need to go ahead and distribute that minus right there. So I do have at the front, I will have the x squared plus 4x minus 8, and then this becomes a minus 6x and a minus 5. And we have a few like terms to combine here. So the 4x and the minus 6x would combine to be a minus 2x. And then the minus 8 and minus 5 combine together to be a minus 13 in total right there. And that's what we're looking at. Okay, so then down here I have the multiplication and the division. So once again, we know that this notation just means to multiply the two functions together. And so let's see, f of x is 6x plus 5. And g of x is going to be x squared plus 4x take away 8. Okay, so the way I'm going to do this is it's kind of like the FOIL process, but we have three terms on my second polynomial. So what I'm going to have to do here is I'm going to have to start by taking the 6x and I'm going to multiply it by all three of these terms right here. So 6x times x squared would be 6x cubed. Then 6x times a plus 4x would be a plus 24x squared. And then 6x times minus 8 is going to be a minus 48x. So that's that first part. Then now what we're going to do is multiply the plus 5 by all three of these. Now, I could continue this out to the right, but it will probably take up quite a bit of room. And so a little trick that we like to do that kind of organizes everything and makes it a little bit easier is I'm going to kind of stack my like terms. So like 5 times x squared, that's 5x squared. So I'm just going to put it in the x squared column right here. Okay, and it's positive, so if you want to put a plus, you can. We're going to add those together in a moment. Then 5 times the plus 4x would be plus 20x's. So I'm going to put plus 20x's right below the x column. Then 5 times negative 8 is minus 40, and I don't have a column for that, so I just make a new column right here out to the right, because you want to go from highest to lowest power. So everything looks good. So the last thing we need to do is just combine those like terms. And so now instead of being written all the way out into my next problem, I kind of stack it, and it's a little bit nice and neat, and it's a little bit easier to combine your like terms. So let's see, 6x cubed plus 29x squared, and then that's going to be minus 28x, and then we do have that minus 40 right there. And so that's what this whole thing simplifies into. Okay, for part D, this is usually one of the easier ones. For the most part, we're not really going to see anything simplify on these, but we will in a later section in Unit 3. So in Unit 3, these we'll talk more about um, functions that look like this. So let's see, my numerator is g of x, which would just be x squared plus 4x minus 8, and then divided by the denominator, which is f of x, which is going to be 6x plus 5. And that's it. You cannot cancel anything out. Okay, like I said, later on in some other units, we might have some stuff like this where we can factor and find some common factors to cancel out, but we're not going to see that here in this section. All right, and so we have another one down here, and you'll notice that in this case, f and g are both defined as trinomials, but really the process doesn't change. There's just a little bit more going on here. So once again, f plus g of x, so f of x plus g of x. So we're just going to add the two functions together. So let's see, we're going to have x squared plus 6x plus 5. And then for g of x, we're going to have plus x squared plus 3x take away 4. And so let's see, we'll consolidate our x squareds. I have two of them. So I've got 2x squared. Then let's see, we've got 6x plus 3x. That gives me a total of 9x's. And then last, I've got a plus 5 and a take away 4. So that would consolidate to a positive 1. So plus 1. And there we go for part A. Part B will be pretty similar, except that we do have to distribute. So we're going to have g of x minus f of x. Okay, well, let's see. G of x is x squared plus 3x minus 4. And then we're going to have to subtract the f of x, so I need to put that in parentheses. X squared plus 6x plus 5. And so we'll go ahead and start by distributing that, and then we'll go ahead and combine our like terms. All right, so now let's see. Oh, that's interesting. So my x squares are going to cancel out, and that's okay. So we're just going to cancel those out. We have x squared and minus x squared. Then we have a plus 3x and a minus 6x, so that can simplifies together to a negative 3x. Then we have a minus 4 and a minus 5, so we'll combine that together to a minus 9. And there we are. All right, so now we're going to multiply them again. Now this one's going to get kind of interesting because it's going to be a trinomial times a trinomial, but it'll be pretty similar to what we saw on the previous example when we were multiplying. So let's see, my f of x, so we're going to take x squared, I'm going to write it over here just so I have more room, plus 6, oops, don't want to forget the plus 5. So plus 5, and then we're going to multiply that by x squared plus 3x minus 4. So pretty similar to the previous one, so I'll try to color code this a little bit. So what we're going to do here is the x squared is going to have to get multiplied by all three of these. Then the 6x will multiply by all three, and then the 5. So let's see, x squared times x squared would give me x to the power of 4. X squared times 3x would give us plus 3x cubed. And then x squared times a minus 4 is minus 4x squared. Okay, now we're going to do the same thing, but with the 6x is going to multiply by all three of these. So let's see, 6x times x squared is 6x cubed. Now, once again, this thing would be written out really far if I just keep tacking them on horizontally. So instead, I'm going to do the vertical columns. So that would give me a positive 6x cubed right here, and we'll combine those in a minute. Then let's see, 6x times a 3x would be 18x squared. So plus 18x squared in this column right here. And then 6x times a minus 4 would be minus 24x. And so I have to start a new column for my x values right here. All right, then last I have to multiply them all by 5. I'm going to multiply them all by 5. So 5 times x squared is 5x squared, so that's positive 5x squared. So I've actually got 3 in this column. Then 5 times 3x is 15x, so plus 15x. And then 5 times a negative 4 is going to be a minus 20. And now we're ready to go ahead and add our columns together, our like terms. So we start out, we just have x to the power 4. Then I have 9x cubed, so 9x cubed. And then here, be careful with your math, but this should add up to 19x squared. And then let's see, this right here is going to add to a negative. It's going to be a negative 9x when you combine those two right there. And then don't forget about the minus 20 on the back end right there. And so that's what we get for part C. Okay, part D, once again, we're just going to do the quotient. So it's going to be g of x over f of x. So g of x was defined as x squared plus 3x minus 4. And f of x was defined as x squared plus 6x plus 5. And they may be factorable, but I wouldn't really worry about that right now. That's something that we're going to deal with in a later unit. So we're just going to leave it like that for now. Okay, I do have, so this is the combination of functions. We still have to do the composite functions. And so I'm going to start a second video for that.